Welcome back to the deep dive. Today, we're really getting into something cool for RC enthusiasts. We're moving past those basic ready-to-run radios, you know the ones, and we're jumping into the deep end with a computerized system, specifically the FlySky FS-i6X.
Yeah, this is where things get interesting. This isn't just a trigger anymore. The FSI-6X, it gives you real precision, tunability. It basically lets you turn a standard model into something, well, truly yours.
Exactly. So our mission today, our deep dive, is to give you that shortcut. We want you to master this radio, but specifically for surface vehicles. Cars, trucks, buggies, you name it.
That's the plan. We're going step by step. But not just the how. We're really digging into the why behind every setting. So you actually understand what you're doing, not just, pressing buttons.
Perfect. Okay, first things first, the hardware basics. Since this radio is technically for airplanes, we're using mode 2. That's standard, right?
Correct. Mode 2. So your right stick, side to side, that's channel 1. Steering, left stick, up and down, that's channel 2. Throttle, brakes, reverse. Simple as that.
And those little switches around the sticks, the trims.
Ah, yes. Trims. Think of those as temporary, like on-the-fly tweaks. If your car's pulling a bit left mid-run, you just tap the trim right a few times. It's not for the permanent setup we're doing in the menus.
Okay, good distinction. Now, before we even think about menus, we need to talk about saving. Because honestly, this trips everyone up initially. I know I've lost settings before.
Oh, yeah. It's probably the #1 frustration point. It's just not intuitive. You'd think a short press on cancel would, cancel. And it does, but it exits without saving.
Right. So what's the secret handshake?
The secret is long press cancel. You got to hold that button down for a solid second, maybe 2. That's what actually writes your changes to memory and then exits the menu. Short press, poof, gone. Long press, saved. Burn that into your brain.
Long press cancel. Got it. That tip alone is gold. Okay, let's move to the bench, wiring this thing up.
Right. So, receiver setup. Usually the FSI-A6B comes with it. Ports are clearly marked. For a typical car, it's pretty simple. Steering servo goes into channel 1, CH1. Your ESC, the speed controller, that plugs into channel 2, CH2.
Okay, standard stuff. And what about that BVCC port? Looks important.
It is. 2 key jobs. First, that's where the bind plug goes when you need to link the radio and receiver. Second, it's usually where the power comes into the receiver from the ESC's BEC normally.
Hold on, BEC. Let's unpack that for folks maybe just moving up from RTR. What's a BEC?
Good point. BEC is battery eliminator circuit. It's built into most modern ESCs. Basically, it takes your main battery voltage, say 7.4 or 11.1 volts, and steps it down. Steps it down to a safe level like 5 or 6 volts that the receiver and servos can actually use without frying.
Ah, okay. So the ESC powers the receiver through that CH2 connection effectively using the BEC voltage fed into the BVCC rail.
Exactly. The ESC manages the power distribution.
Right. Now, binding. We know it connects the transmitter and receiver, but what's it really doing? Why is it so crucial?
Binding creates a unique digital link. Think of it like a secure password. Your transmitter has a unique ID. Binding tells your receiver, only listen to this specific transmitter. Nobody else's. Absolutely vital at a busy track or park. Prevents your car from responding to someone else's radio or just taking off randomly. It's security.
Makes sense. Okay, walk us through the binding steps, precisely.
Okay, everything off first. Power completely disconnected. Step 1, insert the little bind plug into the BVCC port on the receiver. Step 2, connect power to the receiver. You'll see the LED start flashing really fast. That means it's in bind mode, looking for a transmitter.
Okay, flashing LED, now the transmitter.
Grab the transmitter. Press and hold the bind key. Don't let go yet.
Holding the bind key.
While still holding it, slide the transmitter's power switch on in. Keep holding that bind key. Wait. You'll see the receiver's LED stop flashing and go solid.
Solid light means success.
Solid light means success. They're linked. Now, power off the vehicle first, then power off the transmitter.
And the final, absolutely critical step.
Pull out the bind plug immediately. If you forget and leave it in, the receiver goes back into bind mode next time you power up. Chaos ensues. So pull the plug.
Pull the plug. Got it. Okay,
Yeah.
Secure link established. Let's talk safety habits. Runaway cars are terrifying. What's the golden rule here?
A power sequence? It's non-negotiable. Always turn the transmitter on first. Then turn the vehicle on.
Transmitter first, vehicle second.
And when you're done, reverse order. Vehicle off F first, then transmitter off F.
Why is that sequence so important?
It's all about signal and, crucially, failsafe, which we haven't set yet. If you turn the vehicle on first, the receiver wakes up, looks for a signal, finds nothing. And without a programmed failsafe, it might default to, say, full throttle.
Yikes.
Yeah. So transmitter on first ensures there's a valid signal the moment the receiver powers up. Follow the sequence every single time.
Absolutely. Okay, sequence locked in. Let's finally get into these menus. Long press OK.
And now use the UPDWN keys to navigate. We want system setup. Press the OK again to enter.
System setup. Okay. I see model select. Nice. 20 models. And model name. Definitely name your models, people. Trust me.
Saves a lot of confusion later.
What's next in here? Type select. This one looks important.
Critically important. And this is the other big place where surface vehicle users mess up with this radio. You'll see options like airplane, or maybe fixed wing, glider, and then helicopter.
Right.
For your car, your truck, your buggy, you must select airplane. Always.
Okay, but why? It's a car. Why not helicopter? It feels weird choosing airplane.
It does feel weird, but here's why it's disastrous if you choose helicopter. Helicopter mode activates all sorts of complex internal signal mixing, things like swash plate mix. It's designed to control multiple servos working together for helicopter rotors.
Ah, I see where this is going.
Yeah. If you apply that mixing logic to a car's simple steering and throttle, you get chaos. Your steering will go haywire, throttle might link to steering inputs. It makes the car totally uncontrollable, utterly unpredictable.
So, airplane mode ensures a clean, direct signal path. Channel 1 input controls channel 1 output. Channel 2 controls channel 2. No funny business.
Exactly. One-to-one control. Keep it clean, select airplane. Long press cancel to save that.
Done. Airplane mode it is. Okay, exiting system setup. Where to next for tuning?
Now we go back to the main menu list and we want function setup. It looks like a little wrench icon. That's where all the performance tuning lives.
Function setup. Got it. First item, reverse. Seems straightforward.
Usually is. This just flips the direction of a channel. So you go into the reverse menu, select the channel like CH1 for steering.
And if I turn the wheel right, but the car turns left?
You just use the UPDDWN keys to toggle it from normal to rough, or vice versa.
Make it match the input.
Correct. Then that crucial long press of cancel to save it. Do the same check for throttle, CH2. Forward should be forward.
Okay, reverse checked and saved. Next up, endpoints. EPA. What's this about?
Endpoint adjustment, or EPA. This sets the maximum travel limit for your servo in each direction. Left and right for steering, forward and brake or reverse for throttle.
Why is this so important, especially for steering?
Because it saves your servos, period. When your wheels reach their physical steering lock, the linkage can't move any further. But the servo, without EPA limits, will try to keep pushing. That's when you hear that awful, straining, buzzing noise.
Oh, I know that sound. Means the servo is fighting itself.
Exactly. It's drawing lots of current, getting hot, and it will burn out prematurely. Setting EPA stops that. You tell the servo, okay, stop pushing here.
Smart. Saves money and frustration. So how do we set it properly?
Put the car on a stand so the wheels are free.
Okay.
Go into the endpoints menu. Select CH1 for steering. Now turn the steering wheel on your transmitter fully left. Hold it there. Look at the percentage value for the left direction. Probably defaults to 100%. Use the down WN key to start reducing that percentage.
Okay, reducing it. What am I looking for?
Watch the wheels and listen. Keep reducing the percentage until the wheels reach their maximum physical turn, and that straining or buzzing sound just stops. Find that sweet spot right where the strain disappears.
Got it. Max turn, no noise.
Then do the exact same thing for the right side. Turn the wheel fully right, hold it, adjust the right percentage down until the strain stops.
And they might be different numbers, left and right.
Often they are, yeah. Mechanical tolerances, that's why you adjust them independently. Then long press cancel to save those limits.
Okay, EPA set. That makes a huge difference. Now, let's clarify sub-trim versus those physical trim switches we mentioned earlier. People get confused.
Yeah, it's a key distinction. Think of sub-trim as the permanent digital centering tool you use on the workbench. The physical trims on the transmitter face are for those minor, temporary adjustments you might make while driving, like trimming for a slightly uneven track surface.
So sub-trim is foundational.
Foundational, exactly. But it comes with a really important principle. Mechanical first.
Mechanical first, meaning?
Meaning, before you even power things up to use sub-trim, you need to get your physical setup as close to perfect as possible. Get that servo horn on the servo spline as close to 90 degrees, perfectly centered, as you can. Get your steering links adjusted so the wheels are pointing straight ahead mechanically.
Why is that so important? Why not just fix a crooked servo horn with lots of sub-trim?
Because sub-trim shifts the entire range of the servo's travel. If you use a huge sub-trim value, like 30 or 40 points, to straighten things out, you've essentially offset the center point digitally. The consequence, asymmetrical steering. Your car will turn much sharper in one direction than the other because the servo's throw is no longer centered relative to the mechanical limits.
Ah, okay, so big subtrim numbers are a sign of a poor mechanical setup.
Exactly. Use subtrim only for that tiny final tweak to get perfectly centered, maybe just a few points either way.
Yeah.
Mechanical setup first, then fine-tune with subtrim. Long press cancel, of course.
Great advice. All right, moving into the real handling adjustments. Dual rate, DR, and exponential expo. What do these do for driving feel?
Okay, let's tackle dual rate first. DR is basically a limiter on your total steering throw. Think of it like a volume knob for your steering. If you set DR to, say, 80%, you're telling the radio, even if I turn the wheel all the way, only give me 80% of the maximum travel we set with the EPA.
And why would I want less steering?
Stability, especially at speed. Some cars, maybe a light 2WD buggy on a fast straight, can feel really twitchy or overly sensitive to small inputs. Dialing back the DR calms the car down, makes it less likely to dart around with tiny wheel movements, makes it easier to drive straight and fast.
And you can usually assign this to a switch, right? So I could have like 100% for tight sections and flip to 80% for the straight.
Precisely. That's a common use.
Yeah.
Instant stability toggle.
Yeah.
Now, Expo or exponential is different. It's more subtle. Expo adjusts the sensitivity of the stick, but mainly around the center point. It doesn't change your maximum throw like DR does.
Sensitivity around the center, how does that help? We usually add positive expo, right? Like plus 20% or something.
Yes. Positive Expo is common for steering, sometimes throttle too. What Positive Expo does is make the initial stick movement less sensitive. So the first bit you move the stick off-center result in only a small servo movement. But as you push the stick further out, the response ramps up quickly.
So it softens the middle.
Exactly. It creates a sort of soft or slightly dead feeling right around the center point.
And the why for that.
Precision for minor corrections. Imagine driving fast, trying to keep a perfectly straight line. You're making tiny, almost subconscious adjustments. Positive Expo prevents those tiny inputs from making the car dart aggressively. It allows for smooth, fine corrections, but you still have the full, quick steering available when you crank the wheel over for a corner.
Ah, so it's the best of both worlds. Smooth for straights, sharp for turns.
That's the idea. Usually plus 20% to plus 30% Expo on steering is a good starting point for cars. It makes them feel less nervous, more planted. Remember to save with a long press.
Fantastic explanation. Okay, we've tuned performance, but now, arguably the most critical setting in the entire radio for safety, failsafe.
Absolutely non-negotiable. Failsafe is your safety net. It dictates what the receiver tells the servos to do if it loses the signal from your transmitter. Maybe you drive out of range, maybe your transmitter battery dies.
And without it?
Without it, the servo position upon signal loss is unpredictable. It might hold the last command, it might go to neutral, it might go haywire. For a car, we want one specific outcome.
Which is?
Immediate, safe stop. Always. The goal for failsafe on a surface vehicle is to command the throttle channel, CH2, to go to neutral or even apply a small amount of brake the instant the signal is lost.
Makes perfect sense. How do we program that in the FSi6X?
Okay, navigate to the failsafe menu. Inside, you'll see your channels listed. First, select Channel 2, throttle, and turn its failsafe setting on ON. Now here's the crucial action. You need to physically hold the throttle control on your transmitter in the exact position you want it to go to during failsafe.
So for neutral, I just leave the throttle stick centered.
Right.
Or if I want slight brake, I push it slightly forward.
Exactly. Hold that stick precisely where you want it neutral is safest for most electrics, maybe slight brake for nitro. While you are holding that position, do the long press of the cancel button. That saves the current position of that stick as the failsafe command for CH2.
Okay, hold the stick, long press cancel. Got it. What about steering, channel 1?
Good practice to set CH1 steering failsafe to on-N as well, and save it with the wheel centered, so the car stops and tracks straight if signal is lost.
Right. Set both, save both with long presses. Now, we can't just assume it worked right. We have to test it.
You must test it. Every time you rebind, change major settings, or change batteries, it's vital.
How do we do a safe test?
Put the car up on a stand, wheels off the ground. Turn everything on transmitter first, then car. Now apply just a little bit of throttle so the wheels are spinning slowly.
Okay, wheel spinning.
Now turn your transmitter's power switch OF.
Turn the radio off while the car is running. Feels wrong.
It feels wrong,
Yeah.
but it simulates signal loss safely. Watch the wheels. They must immediately stop spinning. Instantly return to neutral or your slight brake position.
And if they keep spinning, or worse, speed up.
If they don't stop immediately, your failsafe is set incorrectly. or it didn't save. You must go back and repeat the failsafe setup procedure right away. Do not drive the vehicle until it passes this test.
Understood. Fail-safe test is mandatory. Wow, okay. We've really covered the essentials here. We went from just plugging things in to binding securely, setting the fundamental system type, avoiding that helicopter mode trap.
Then dialing in the field with EPA to save servos, using subtrim correctly after a good mechanical setup, and adding that finesse with dual rate and expo.
And topped it off with the critical failsafe. We've basically taken, say, a simple Tamiya Hornet and given it a sophisticated brain transplant. It's now tuned, protected, and safe.
Precisely. All those steps transform it. Now, we've covered the core functions you absolutely need. But there's always more depth, isn't there? Right there in that Functions S menu, there's also throttle curve. And they didn't dive into that today, but it lets you move beyond just linear throttle.
Ah, so you could make the throttle less aggressive right off the line.
Exactly. You could program a curve that's really soft initially, helping you get much better traction and smoother acceleration on, say, loose dirt or slippery surfaces, another layer of fine-tuning.
Interesting. So a final thought for everyone listening.
Yeah, think about that throttle curve. We've shown you how to set the basics for control and safety. Now, the question for you is, how might you use something like throttle curve to customize your launch, to really refine how your vehicle puts power down in specific conditions?
Food for thought indeed. That's all the time we have for this deep dive. Thanks for walking us through that maze of settings.
My pleasure. Happy tuning.
And thanks to all of you for listening. We'll catch you on the next deep dive.